Alright, so now we're going to just continue working with more difficult radical equations. Again, I've got the 5 steps there up on top. This example has a couple different terms on the right, but still has one radical on the left. So I don't have to isolate the radical, it's already by itself. I do need to square both sides, so that's the first thing we'll actually do here, is raise both sides to the second power. On the left, the square of the square root, they both disappear and you're left with just what's underneath. On the right side though, x minus 7, this whole thing is being squared. Now I'm not squaring each term. Okay, this is the part where a lot of people make mistakes. You really have to square the whole side. And so what you end up with is x minus 7 multiplied by itself. That's what squaring does. It's just like the FOIL method or distributive property that we learned in chapter 5. Alright, so here we're going to go ahead and do that distributing. That's going to be x squared minus 7x minus 7x plus 49. And now if I step back for a second and take a look at this equation, I have a quadratic equation because it has an x squared. And to solve these, we learned in chapter 5 that we have to get a 0 on one side and then factor the other side. Okay, this was the end of chapter 5, section 7, where we did this. And so I need to get a 0 on this side, so I'm going to subtract the 2x. Now I could also combine these, so this is actually going to be negative 14 minus a 2x. So I'm just going to throw them all together at the same time. Alright, so I get the 0 on the left, and we're going to get an x squared. Negative 14 minus 2 is negative 16. And then this is a 48. Right, 49 minus 1. Now, to solve this, I need to find the factors of the right side. And because the leading coefficient is 1, I can jump right to the answer. Once I know factors of 48 that add up to negative 16. Alright, well, you may have guessed it by now, but the answer is going to be 12 and 4. Both of them have to be negative to get the positive constant here. So we're going to have x minus 12 and x minus 4. Alright, now we're going to set each of these factors equal to 0. So the first one is x minus 12 equals 0. Second one, x minus 4 equals 0. And then we add the 12, you get x equals 12. Add the 4, you get x equals 4. Oops, there we are. And so it appears, move this right up to the top, that I have 2 answers, but remember I have to then check the possible answers because some of them may be extra or extraneous is what we call them. And so I'm going to go ahead and do the check. Oops, C-H-E-C-K, there we go. I'm going to check the 12 first. When I put the 12 in, I get a square root of 2 times 12 plus 1 on the left. And they get a 12 minus 7 on the right. I've got to make sure these end up simplifying to the same thing. So 2 times 12 is 24. 24 plus 1 is 25. And the square root of 25 is 5. On the right side, 12 minus 7 is 5. Because they end up being the same, we'll say that one checks out. Okay. If I check the 4, let's plug that in. I get 2 times 4 plus 1. And then I get 4 minus 7. Okay, so in this case I get, under the square root, I get 8 plus 1 is 9. The square root of 9 is 3. On the right side, 4 minus 7 is negative 3. These two things are not the same, and so 4 actually does not check out. Okay, I'll just say no. Now the final answer needs to be whatever solutions do check out. We'll say that the 4 is extraneous. Okay, 4 is extraneous. 5 is a solution, so I'm sorry, 5 is not a solution, 12 is a solution. And so the final answer, and again, you want to write this out in solution set form, is the answer 12. Okay. Alright, that was a good problem. It introduced a few things that are unique that we haven't seen already. Alright, let's take a look at a couple more problems. Alright, this next one, we're going to take two square roots and set them equal to each other. So we have the square root of 6x plus 2 equal the square root of 5x plus 3. Now when you have two roots equal to each other, it doesn't really matter what they are, as long as you can isolate one. Now in this case both of them are isolated. They're each by themselves on their side of the equation. So we can jump right to squaring both sides. Square the left, square the right. Now again, the square of a square root, they drop out, you just get the stuff underneath. And on this side, the square of a square root again just is the stuff underneath. Okay. Alright, and now we're going to solve the equation, the resulting equation as is. If I were to subtract the 5x from both sides, I get an x plus 2 equals 3. Subtract the 2, and I just get x equal to 1. Now again, we want to check this. Always need to check on squaring. So we try the 1 in there, you get the square root on the left of 6 plus 2, right? 6 times 1 plus 2. That's the square root of 8. On the right side, you end up with the square root of 5 plus 3, right? 5 times 1 plus 3, which is also square root of 8. Okay, square root of 8 and square root of 8 are the same, so that does check out. So our final answer should be the 1 in a solution set. Alright, final example. This one's a little bit harder because it's going to involve multiple roots again. We're going to take the square root of x minus 8 equals the square root of x, and then a minus 2 on the outside. Okay. So here I've got to isolate a variable, isolate a root, and this time I have one isolated again. And so when I square this, the one on the left will disappear. The one on the right, however, is going to be included in another square, but don't forget, we're not squaring each term, we have to square the whole side. So on the left I get the square of a square root is just the stuff underneath. But on the right side, we're really dealing with root x minus 2 times root x minus 2. Now we saw stuff like this in the last section when we did the more complicated multiplication problems. And we have to solve this in the same way. So we use the FOIL method. You're going to do root x times root x is just x. Root x times negative 2 is negative 2 root x. Here's another negative 2 root x. And here's a plus 4. Alright, so we're going to do some simplifying. Now I get x minus 8 equals x minus 4 root x plus 4. Notice the two terms in the middle don't drop out, they actually add up. And so I haven't eliminated a variable, or I haven't eliminated all my radicals. I still have a radical. So I need to isolate this radical. So the next step is to move everything away from this root. To do that, I'm going to first subtract this x from both sides. That eliminates it here. But it also eliminates it on the left. That's kind of nice. May not always do that. I'm going to subtract this 4. That's going to give me a negative 12 equals negative 4 root x. Again, I still have to eliminate or isolate this root, so I'm going to get rid of the negative 4 by dividing it out. I'll cancel out there. I get 3 equals the square root of x. And so at this point I need to square both sides again. As soon as I isolate a root, I can square both sides, but I have to get the root by itself first. Left side is 9, the right side is x. It appears that 9 will be our answer. Let's just double check. Okay, and so on the left side I get root of 9 minus 8, which is the square root of 1, which is 1. On the right side I get the square root of 9 and then subtract the 2. Square root of 9 is 3. 3 minus 2 is 1. Because they're equal to each other, this does check out. And so our final solution is the 9 in a solution set. Okay. There may even be some examples where none of the answers you get check out. That is a possibility. And if that is the case, then you just have no solution. You can use the empty set then as your answer. Okay. Again, you must isolate a root in order to square both sides. So notice I did not square both sides again until I had that root by itself. The other thing you have to remember is when you square a side, you must square the entire side. So if you have more than one term, you have to use the FOIL method to square it. Here I only have one term, it's just this one root. Even though there's 2 terms underneath, it counts as 1 with the root, and so the square of the root disappears. Okay? So if you have more than one term, you have to expand in FOIL. Otherwise, you can just eliminate the root. Okay? Alright, that does it for radical equations. Thanks.